Dear participants, my name is Ivan Pavlenko. I'm representative of Sumy State University. I'm a professor at Sumy State University Department of Computational Mechanics, named after research articles to our journal. It's a great honor for me to be a chair of this session number 8. The today's sessions named as Chemical Engineering, the second part. Remarkably, the session is based on recent developments in chemical engineering, energy efficient technologies, and industrial ecology. It consists of 5 researchers carried out by 25 representatives from 7 institutions from 4 countries, such as Japan, Poland, Kuwait, and Ukraine. Please pay attention that you have 8 minutes for your presentation. The discussion, answers, and questions will take 2 minutes. I cordially ask you, all the participants, to make their answers to be involved in each discussion. Okay, let's begin our session, and I sincerely wish all the speakers to make the presentation successfully and share their contributions and latest achievements with your international scientific community. The first presentation is Equipment for Oilfield Wastewater Treatment using Swirling Flows by authors Alexander Lepощенko, Viktor Moiseyev, Alexander Starinsky, Evgenia Manoylo, and Houssein Seif from Sumy State University, Ukraine, National Technical University, Kharkiv Polytechnic Institute, Ukraine, and Al-Kharayev Company for Sale, Maintenance, and Repair of Oil Production Equipment, LLC, Kuwait. And the speaker is Houssein Seif from Al-Kharayev Company for Sale, Maintenance, and Repair of Oil Production Equipment, LLC, Kuwait. You are welcome, please.
Thank you. Good afternoon, sir and madam. I would like first of all to thank the organizers of this meeting for inviting me here today. Welcome to my presentation. What I would like to present to you today is equipment for oil field wastewater treatment using swirling flow. Next flow, please. Next slide, please. I'm not seeing the slide in the windows. The oil and gas industry is one of the most environmental dangerous subsurface use industry and causes huge damage to the environment. It's characterized high energy intensity, significant pollution of vast territories. Petroleum products and reservoir water are the main environmental pollutants in this area. Reservoir water released to the surface changes to the micro relief of the territory, and it's a source of secondary salinization of soil around oil wells. Reservoir water contains petroleum, hydrocarbon, various salts, and mechanical impurities, which being absorbed by the soil and entering the groundwater dramatically change their chemical and physical properties. Recently, when developing oil well, the technology of injecting produced water into the well to maintain pressure is used. More than 90% of oil field wastewater is used for flooding oil reservoirs. Flooding of oil reservoirs allow increasing oil recovery by 1.5 to 2 times. Next slide. The current scheme of pumping wastewater back into the reservoir at oil field with the addition of reagent to increase oil recovery leads to a significant change in the chemical composition of reservoir waters, which affect the state of the subsurface and also creates a threat of spreading pollution to other aquifers. In solving this problem, one of the main tasks is to purify oil-containing reservoir wastewater in order to achieve stable characteristics of the natural environment with acceptable parameters of contamination, as well as possible extraction of valuable component from recycled water. Next slide. Oil field wastewater purification is carried out by mechanical and hydromechanical process, mixing, settling, centrifugation, and filtration in order to destroy the armor shells on oil droplets, coalescence of oil droplets, and remove of partially concentrated oil phase and sediment. For the treatment of reservoir wastewater in the oil industry, the method of settling and settling tank is used. But this method often does not provide the necessary degree of cleaning. Therefore, tanks with agitators, settling tanks, separators, centrifuge, hydrocyclone, drop forming units, flotators, and filters are also used as equipment. In order to successfully purify oil-filled wastewater for quickly reduce the aggregative and kinetic stability of oil dropless oil-filled wastewater purification units and devices are developed that increase the effect, depth, and speed of the purification process. Due to this, oil droplets are rapidly enlarged to coalescence process. A polydisappears system turns into a monodisappears one. A high and stable effect of cleaning oil-filled wastewater can be achieved by pre-hydrodynamic treatment of it in a swirling steam. Next step. Next slide. In hydrocyclone and sedimentation chambers, the armor shells are destroyed. The oil droplets are fragmentary and coalesced. The monodispersity increases. Due to hydrodynamic treatment of the swirling flow, a high and stable effect of swirling cleaning is achieved in all areas of the swirled flow. The swirling flow is expanded, the swirled flow is properly damped. The flow energy is used for the most effective implementation of the mechanism of destruction of oil emulsion. The separation of oil droplets from water in an emulsified state is performed in cylindrical counter-current hydrocyclones of small diameter. The treated water entering the hydrocyclone through the tangential inlet receives a rotational movement under the influence of the resulting centrifugal force, which exceeded the force of gravity by hundreds or thousands of times. The particles of impurities are thrown into the external drawn flow, which moves in a spiral to the lower discharge port. Next slide. The use of hydrocyclones as a stage of wastewater treatment can significantly increase the compactness of the entire treatment scheme and facilitate its operation. For water purification from oil and suspended substance, depending on the required degree of purification, the following devices are used. One, at the first stage of cleaning, hydrocyclones and settling tanks. Second, in the second stage, hydrophilic and hydrophobic filters. Three, for better water purification, coalescing filters. The separation mechanism of three-phase system in hydrocyclones is as follows. Solid particles under the action of centrifugal force move to the wall of the hydrocyclone and along a helical trajectory move down to the lower outlet, through which they are removed from the hydrocyclone. The efficiency of the water purification from oil depends on the design of the hydrocyclone and varies from 84 to 89%. Recommended parameters of the hydrocyclone: diameter of cylindrical part 75 mm, diameter of inlet port 15 mm, diameter of the axial port 10 mm, diameter of the discharge port 20 mm, taper angle 10 degrees Celsius, inlet liquid pressure 0.17 megapascal. Next slide. The research methodology. In this article shows some technology parameters and values for calculation of cyclone installation. As you can see, so the multi-hydrocyclone can be used as the main element in the wastewater treatment system, provided the regime is observed in which there is no overexpression of the remaining oil in the water in oil. The acceleration of movement does not exceed the value of 1,000 grams. The device implements a mechanism for separating light oil gas and heavier fraction water in oil. Next slide. In this slide, multi-hydrocyclones make it possible to achieve a deep degree of purification, and their use is promising both in the system oil-filled wastewater treatment and in system of primarily water discharge. it's advisable to treat oil-containing wastewater for reuse in accordance with this scheme. The oil-containing wastewater flows into a receiving tank, sometimes into a pre-sump. Then the wastewater is sent for treatment by pumps, in particular the pressure hydrocyclone, in which large mechanical impurities are separated and dumped into a hopper. After passing through cylindrical conical hydrocyclones, thin layer settling tanks, wastewater enters in cylindrical hydrocyclones for purification from petroleum products. After hydrocyclones, the purified water is sent to flotator, coalescing or sorption filters. If necessary, the final purification of water in the sorption filter to the content of petroleum products of 0.05 milligram per liter is possible. Next slide. The treated water is returned to the well, maintain reservoir pressure, the cleaner the water being pumped into the formation. The greater the intake capacity of the injection well, and the lower the required amount of water, and the lower the cost associated with pressure maintenance system. General requirement for pumped water is limited content of mechanical impurities and iron components, absence of hydrogen sulfide and carbon dioxide to prevent equipment corrosion, no organic impurities like bacteria, algae, chemical compatibility with reservoir water. The degree of oil wastewater purification is determined individually for each oil well. The permissible content of mechanical impurity is 3 milligram per cubic decimeter, and petroleum products 5 milligram per cubic decimeter. The presence of mechanical impurities is one of the main factors that cause a decrease in the permeability of the bottom hole formation zone when using both fresh and reservoir waters. Next slide. The results of hydrocyclone simulation method are present in this figure. CFD simulation of separation process in SPR separator. In the left, counters of the water volume fraction in the middle section of the SPR separator, and in the right, can see the vectors of water velocity. The result of the numerical simulation point out that the action of centrifugal forces are provide separation efficiency. The separation efficiency was calculated using the dependence and its compounds. The usage of these separators type at the separation oil product stage may significantly increase the degree of wastewater treatment and the intensity of the present units. Slide 11. The conclusion. Modern industrial methods of oil field development require the use of new equipment with a high cleaning effect and a single capacity, tightness, and easy of factory, the manufacturer, and installation. The amount of capital investment for the construction of treatment facilities is reduced several times, and operation costs are reduced by 15%, improving the sanitary and environment condition of operation of the plant. No less important advantage of the scheme with hydrocyclone is significant space savings. Thus, in order to protect the environment, the following measures are necessary. First, ensuring deep treatment of oil field wastewater. Extensive use of anti-corrosion coating and chemical reagents for corrosion protection of oil-producing equipment. Full use of wastewater obtained in the field in the reservoir pressure maintenance system. Monitoring of the state of surface water and the quality of wastewater used in the reservoir pressure system. The developed methodology was released within the research project and implementation of energy efficiency modular separation device for oil and gas purification equipment. Thanks for your attention. Thanks.
Dear Dr. Houssein Seif, thank you for your interesting presentation. And now we have one question from our chat. So please answer the following question. Slide 7 present velocities for laminar and turbulent modes. In this regard, maybe it would be better to propose the unified dependence of particle precipitation velocity on the Reynolds number. And have you considered resistance forces of different nature, like such as drag forces, historical Basset forces, or many other forces, or maybe it will be your research in the future?
It will be in the future, our research for the other forces. Now we are focusing on Archimedes force and centrifugal force in this case.
Okay, thank you. Thank you for your presentation. Thank you for your answer for these questions. And I highly appreciate your participation in the conference. And thank you. See you.
Thank you. Thank you. See you soon.
Colleagues, the second presentation is thermal characteristics of the wet pollution layer on condensing